images is done through the addWeighted function that uses both images and combines them. We require 2 input images, which may have varying dimensions. The prerequisite for image blending is that both images must have identical dimensions. Therefore, it is essential to resize these images to a uniform size. Let's practice resizing the image, since the do not copy image is actually quite large, 1200 by 1200, and our puppy and backpack image is 1400 by 1000. Using OpenCV's addWeighted function, we will blend the values together with the formula as shown above. When combining 2 images, the function blends the pixel values of the 2 images according to a specific ratio to create a new pixel. The values of alpha and beta range from 0 to 1. When the value of alpha approaches 1 and the value of beta approaches 0, the pixel underscore 1 of the first image is given more weight, making it more prominent than pixel underscore 2 of the second image. We can use this quick trick to quickly overlap different sized images by simply reassigning the larger image's values to match the smaller image. Instead of using a blending, we'll scale the second image and layer it over the first. Select the coordinates of the first anchor point and provide the coordinates of the second image's anchor point to overlap it on the first image. Thresholding is fundamentally a very simple method of segmenting an image into different parts. Thresholding will convert an image to consist of only 2 values, white and black. Typically, color images hinder the clear identification of image features. Therefore, we convert them to grayscale before applying thresholding for image segmentation. There are different threshold types including binary, inverted binary, truncated, to 0 and to 0 inverted. For binary thresholding, a pixel value is set to the maximum value, white, if it is greater than or equal to the threshold value, otherwise it is set to 0, black. Binary inverse thresholding is the inverse case of binary thresholding. For truncated thresholding, set the pixel value to the threshold value if it is greater than the threshold. Otherwise, keep the original pixel value. For 0 thresholding, if a pixel value is greater than the threshold value, set the pixel value to the threshold value. Otherwise, set it to 0, black. To 0 inverse thresholding is the inverse case of to 0 thresholding. A common operation for image processing is blurring or smoothing an image. Smoothing an image can help get rid of noise or help an application focus on general details. It is combined with edge detection. Edge detection algorithms detect too many edges when shown a high-resolution image without any blurring. Read a color image and convert it to the RGB color space. We will learn about a method to adjust image brightness and contrast called gamma correction. It makes image appear brighter or darker, depending on the gamma value. If a photo is underexposed, we can increase brightness by reducing the gamma value to less than 1. If the photo is overexposed, we need to reduce the brightness, which can be achieved by increasing the gamma value to a number greater than 1. Now, let's move on to kernel-based filter. A filtering operation known as 2D convolution can be used to create a low-pass filter. Kernel can apply over an image to produce a variety of effects. The best way to explain this is through an interactive visualization. Put in text bricks into an image. Create a 5 by 5 kernel filled with 0.04 by dividing a 5 by 5 matrix of 1s by 25 using NP ones. Apply the previously created kernel to the image using OpenCV's filter 2D function. After applying the kernel, the resulting image appears smoother due to reduced noise, but edge details, such as the brick's stroke, are sharpened.